Okay. Good morning, good evening, wherever you are. Uh, Depending on what time you're tuning into this channel. My name is Mameja T. I'm going to be teaching you guys mathematics. We are going to be doing grade 9 content. We are going to be focusing on term 1. So on this lesson, we are going to be looking at the first topic, which is our real number system. So the rest of the information I'm going to be sharing with you guys throughout the lesson. Um, yeah, if you can just look on the screen there, I prepared some document for you guys to go through with you. I'm also going to share this document with you. I will type in the link on the description box for those who want to download the document in a PDF format. I also would put some important information, especially my handles for other social platforms such as TikTok and others. Without further ado, let's get started. All right, I'm going to go to the first page of the document. There we go. So let me start by erasing this. Yeah, perfect. Yeah, like I said, the purpose of this lesson today is to look into the real number system. So we're only going to look at the real number system, and there are some activities that we're going to do together in the next slides. So in the activities, guys, I would want you to pause the video, try to work them out before I give you the answers, just to check if you still remember these things, because these things were done sometime in January. So don't just, you know, don't just look for me to write the answers, because in a way you won't be prompting yourself, you won't be learning anything. Yeah, guys, let's start. On the screen, I displayed you the chart or a diagram for the real number or the real number system. So if as you can see on the screen, real numbers are divided into two categories or two branches. We have rational numbers, which they use the letter Q, and irrational numbers, which they use the letter Q with some hyphen. Let me activate my pen. Yeah, so guys, so these ones, they use the letter Q with some hyphen. So guys, I hope you will forgive me for my annotation skills, since I'm new to this pen tablet, but I think I'm gonna improve along the way. Let me change the dimension of my pen. I would like to write in bold. Real number or the real number system can be divided into two classes, which is rational numbers and irrational numbers. So these are the numbers which we can find in the number line, guys. So they are divided into rational numbers and irrational numbers. So I want to start discussing about rational numbers. So rational numbers, guys, they say these are the numbers which can be written in the form A over B. So these numbers can be written as a fraction, right? Whereas these numbers, irrational numbers, cannot be written in or as a fraction. So these numbers, which are rational numbers, guys, they include all whole numbers, integers, and natural numbers. So They include whole numbers, natural numbers, and integers. So these numbers also include non-integer rational numbers. So non-integer rational numbers here, we talk of improper fractions, proper fractions, and we also talk about um, recurring decimals and terminating decimals. So I think just to add another branch there, we can add recurring decimals and terminating decimals. So for recurring decimals, what are we talking about when we talk of recurring decimals? Recurring decimals, example of recurring decimals, if I just use this space below there, just to indicate examples of recurring decimals. So recurring decimals, guys, are the decimals numbers. They are the decimal numbers which recur. So what do we mean by that? So for an example, a number 1/3, if it's written as a decimal, this number is going to be 0, 3. So this decimal is going to recur up to infinity. So this number, we call it a recurring decimal because it has got infinite number of decimal places. So what do we talk of when we talk of terminating decimal? So an example of terminating decimals are numbers such as 0.5, 0.25, something like 0.123, because these numbers, we say these numbers are terminating decimals because they have a finite number of decimal places. So their decimal places do not recur, and they also terminate. So we call them terminating decimals. So they fall under rational numbers. So in a way, rational numbers include integers. In integers, remember, we find negative numbers, whole numbers, natural numbers, including a 0. They also include non-integer rational numbers. So non-integer rational numbers, in a way, they are referring to decimals, such as recurring decimals and terminating decimals. So I hope that it's understood. So if you can look at the statement there, they say non-integer rational numbers include common fractions and decimal fractions, especially recurring and terminating decimals. So whereas, guys, irrational numbers, so these are the numbers which are not rational. So in a way, so these numbers do not fit into this branch of rational numbers. So they are classified as irrational. So what do they include? So this number include non-terminating, and non-recurring decimals. So the decimals do not recur and they do not terminate. So these numbers, actually, we are referring to the decimals with infinite number of decimal places which do not recur. So an example of this number, it's numbers such as pi, which is 3,141 something something. So pi, guys, have infinite number of decimal places. So the decimal places of pi, as much as they do not recur, meaning they do not repeat themselves, they do not end. They keep on repeating and repeating and repeating without recurring up to infinity. So the reason why pi is classified as or it falls under rational numbers is because of its infinite number of decimal places. We also have a square root of 5, which is going to be 2 comma something 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 something. I'm not sure it's 2 comma what, but the square root of 5, for an example, also as a decimal, do not have recurring decimals or do not have terminating decimals. So hence it is also called non-terminating and non-recurring. So the other example would be something like the square root of 6. Okay, let me write 6 properly. The square root of 6 there. So as much as this number may look like it's a rational number, but this number actually, guys, is not a rational number. This number will still give us something like 2 comma something 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 with decimals which do not recur and do not terminate. So for as long as it's a square root of a number, that is not a perfect number. So a square root of any number that is not a perfect square number will become non-terminating and non-recurring decimal. So that number will qualify to be an irrational number. So yeah, that is all about rational numbers and irrational numbers. So the only difference here, guys, is that rational numbers, they include a lot of different types of numbers. They include whole numbers. We know under whole numbers, we can have natural numbers. We can also have zero. They also include integers. In fact, I wanted to say, and integers, we can have whole numbers, natural numbers. So they also include non-integer rational numbers. I talked of recurring decimals and terminating decimals as opposed to non-terminating and non-recurring, which fall under irrational numbers. So irrational numbers are only non-terminating and non-recurring decimals. So guys, I hope that is understood. If there's something which maybe I explained fast, you can always pause, or you can always go back to your a part where maybe I explained something you did not get it. You can always reverse. We used to call it reverse back in the days. I don't know whether it's to reverse or to rewind, but you know what I'm talking about. You can always go back and listen carefully. And if also there are questions, you can always drop it also on the comment section. I will just check after a few days, maybe. But I will try to respond as quick as I can to your questions. All right. On the next slide, guys, it's just an activity that I want us to do. So on this activity, we going to classify the numbers either as rational or as irrational, and in other categories as well. So before we go on to the next slide, maybe just a final recap of this type of numbers. Real numbers, I said, guys, real numbers can be divided into rational and irrational numbers. So when we talk of rational numbers, we talk of all integers. So integers, guys, you know, would include numbers from negative infinity to positive infinity, including zero, the numbers which are without a fraction or a decimal. So, and integers would include all whole numbers. They will also include natural numbers because natural numbers are also found in the range of integers. So, like the whole numbers can also be found inside integers. And the other ones that also follow under rational numbers, we talked of non-integer rational numbers. So meaning these numbers are neither rational, nor whole numbers, nor natural numbers. So these numbers are recurring decimals and recurring decimals and terminating decimals. So when you talk of recurring, like I said, an example, it was there, the number 0,3333, which can also be written as 0,3. Then you put just a small dot on top of 3 there to show that the decimal 3 recurs. So it was the first example. It was the example of recurring decimals. So terminating decimals, I gave an example of 0,5. 0,55 is the last decimal there. 0,255 is also the last decimal there. 0,1233 is the last decimal there. So that is all about this type of numbers. Again, guys, please forgive me for my handwriting. I think I will improve as the time goes on. Thank you. Let's now go to the next slide. Yeah, guys, you can see on the next slide, they say complete the following table. Let me see if there's nothing up there. Okay, there's nothing up there. Let me drag it this side. It says complete the following table. So here, so we are going to classify these numbers on the first column. Either they fit into natural numbers or they qualify as whole numbers or not, or qualify as integers or not, or qualify as rational or not, or qualify as irrational or not, or qualify as real numbers or not. And guys, let me just indicate something on real numbers. If a number is not a real number, it means that number is non-real. And on the real number system, the non-real numbers are not included because anyway, they do not form part of the system. But the question would be, what type of numbers are not real? So the numbers which are not real, guys, before we can even go there, let me just go that side. The numbers which are not real are the numbers which will give us something like undefined or an error, even when we do them on a calculator. An example of such numbers would be, let me do my pen. Example of such numbers which are non-real numbers. So example number A would be a square root of -4. So if you check or you punch even on a calculator, square root of -4, some calculators will write something like undefined. Some calculators will write something like an error. So it means a calculator, even a calculator itself, it cannot process this number. So this number is non-real. So this number cannot even be found on the number line. So number B it can be something like 1/0. So you dividing a number by 0 also is it's undefined. So even a calculator, it can't give you the exact answer for that. So these numbers are the numbers that we say they are not rational numbers. Neither these numbers are irrational, hence they can be categorized as non-real. So guys, can we go now and complete this? So guys, just to make sure that maybe you understood or grabbed this as a concept, just and also for the purposes of just to check if you still remember what was done in term 1, you can just pause the video and try to work these things out very quick, even in your mind without writing them down, or you can even write them down and pause, write them down, try to work them out, and yeah, and check the video to check if you got them correct or not. And let me also, guys, remind you, if you already are following this lesson and you already also like the content of this lesson, you can just click the subscribe button there, just to make sure that you don't miss out anything that we are going to post going forward, because this channel is going to be dedicated to grade 7, 8, and 9. So that is senior phase. So we are going to be posting videos of lessons, and also we are going to be doing these activities together, guys. So please, you can just hit the subscribe, and you can also hit the bell there, just to make sure that every time we post that, and you don't miss out everything. So yeah, guys, shall we? Okay, let me activate my pen. Okay, the first one, guys, the first number that we are going to tell whether it's natural or not natural, it's 0. So if you can just look at the first row there, they gave an example of the number 3. So the number 3, they answered there from natural to real there. They answered for you as an example. So that when you can answer the rest. For an example, number 3. So the question was, they wanted to know whether that number is natural or not natural. So the answer is no. So meaning that number is not a natural number. Remember, natural numbers, they are counting numbers starting from 1. So is -3 a whole number? No, whole numbers are counting numbers starting from 0. Is -3 an integer? Yes, -3 is an integer. Remember, integers, they start from, they are counting numbers without decimals, starting from -infinity to +infinity, including 0. Is it a rational number? Yes, it's a rational number. So is it an irrational number? No, a number cannot be both rational and irrational. So since the number is rational, so it cannot be irrational. So is the number a real number? Yes, it's a real number. That number can also be found even on the number line. So number 1, shall we? Yes, we shall. So guys, I'm going to use the X and the tick to indicate whether it's no or yes. So my X in this case, it would mean a no, and my tick, it would mean a yes, so that I complete this thing as quick as possible, so that it doesn't, consume a lot of time and your data there. Guys, data is very expensive. Some people call it a digital gold. So we need to use it wisely. Okay, number A, 0. Is 0 a natural number? No, 0 is not a natural number. Remember, natural numbers start from 1. Is 0 a whole number? Yes, whole numbers start from 0. So is 0 an integer? Yes, 0 is an integer. Is 0 a rational number? Yes, integers are rational numbers. Is 0 irrational? No, it can't be rational and irrational. Is the real number? Yes, it's a real number. Done with 0. So the square root of 7, guys, we talked of the square root of non-perfect square numbers like 7. 7 is not a perfect square number. So a square root of 7 will give us decimals, and those decimals will be non-terminating and non-recurring. So if you remember, non-terminating and non-recurring fall or fell under irrational numbers. So they are neither natural, no whole numbers, no integers, neither are they rational, they are irrational. Are they real? Yes, this number, it can be found on the number line. So it's a real number. So a pi. So a pi, if you remember, even if you punch it on a calculator, it will give you some decimals which do not recur and do not terminate. So this number, I also indicated it on the examples of non-terminating and non-recurring. So is it a natural number? No, it is not. It is a whole number. No, it is not. It is integer. No, it is rational. No, it is irrational. Yes, it is a real number. Yes, it's a real number. So the other number, guys, is negative 2 over 3. So negative 2 over 3, it's a, so if you punch it on a calculator, this number is going to give you negative 0.666666, if I'm not mistaken. So is that a natural number? No. It's a recurring decimal. Is that a whole number? No. Is that an integer? No. Is that a rational number? Yes, it's a rational number. Is that irrational? No. Is that a real number? Yes, it's a real number. So another number, it's 0.73. So if you look at on top of 3, there's just a small dot right on top of that 3. So that small dot indicates that this number 0.73, it's a recurring decimal. So if we were to write this number would be written as 0.73 with a dot on top. This number would be written as 0.73333333. So the trace will recur up to infinity. So this number is a recurring decimal. So is it a natural number? No. Is it a whole number? No. Is it an integer? No. Is it a rational number? Yes, guys, recurring decimals are rational numbers. Is an irrational? No. Is it a real number? Yes, it's a real number. So the other number there is 1,2357. So what type of a number is this? Guys, you remember we said this number is a terminating decimal. Why terminating? Because there's no indication, none whatsoever, on the 7 or on any of those decimals to show that those decimals recur. So that has to be a terminating decimal. So is that natural? No, it's not natural. Is that a whole number? No. It's a decimal. Is that integer? No. Is that rational? Yes, it's rational. Is that irrational? No. Is that a real number? Yes, it's a real number. So the other one, guys, it's pi over 3 pi. So maybe let's just try to work this number out, just to look at its value. So let me take my hand there. So I'm gonna have to move this side. I'm gonna have to move this side. So let me start by erasing my eraser there. Yeah, just to make sure that it's clean. Okay. Yeah, let me. Okay, so that's we work out that number. So that number is number G. That is G, which is pi over 3 pi. So this number, guys, if we were to work it out, you can use a calculator or you can just work it out mathematically. So this is the same as pi over 3 times pi. So if we have a number like this, you know that it's possible that we divide this pi and pi together. They must give us 1. So, or you can use the highest common factor, which is pi. So pi into pi, it goes once. Pi into pi, it also goes once. So our numerator now is 1 over 3 times 1 is going to be 3. So this number, if you check on a calculator, is going to give you 0, 3, 3, 3, 3, 3, 3, 3. So the decimal 3 will recur up to infinity. So we can represent this number as 0, 3 with a small dot there on top, because this number is a what? It's a recurring, decimal. Please forgive my handwriting. Let me go back to my page to go and fill my table. Let me activate my pen. So that number is a recurring decimal. So is that a natural number? No. Is that a whole number? No. Is that an integer? No. Is that a rational number? Yes, it's a rational number. Is that irrational? No. Is that... Okay, guys, no matter that this number has a pi, so it doesn't matter if this number has a pi, for as long as we work out the value of a number, it gives us something which is not part of irrational number. So when we work out that number, it gave us 0.333, and 0.33 is not irrational number. It's a recurring decimal, so it qualifies to be a rational number. So number H, 3 divided by 0. So if we divide a number by 0, like I indicated before, so your calculator will indicate undefined. So it means even the calculator itself, you cannot process the number. So is this number natural? No. Is it whole number? No. Is it integer? No. Is that rational? No. Is that irrational? No. So this number is not a rational number. Neither is this number a rational number, because it does not fall under either of them, whether rational or irrational. So is that number real? No. So this number is non-real because it gives us an error or undefined on a calculator. So I want to start by erasing this part. I think there's some mistake there. Yes, now it's fine. Let me activate my pen. So we have a number I, which is square root of 2 whole number 1/4, or square root of 2 1/4. So can we work the number alongside there? So let me activate my pen. So this number I is what? The square root of 2 and 1/4. How do we work out this number? So we can simply change this mixed fraction into improper fraction. And how do we do that? We know from grade 7 and grade 6 that you multiply this numerator 4 by 2, which is going to be 8. 8 plus 1, it's 9. And the denominator does not change, it's still 4. So this number, the square root of 9 over 4, is the same as the square root of 9 over the square root of 4. And the square root of 9 is 3, the square root of 3 is 2. And this number, we know 2 into 3, it goes once, remainder 1 over 2. So this number can also be written as 1.5, 1.5. So the question is still if that number qualifies to be a natural number, and that number is 1.5. So this number is not going to qualify. Let me activate my pen. So this number is not going to qualify. So it's no. Whole number? No, it is a decimal. Integer? No, it is a decimal. Rational number? Yes, it's a rational number. Okay. So this number can never be both rational and irrational. This number is real. So let's do this one quickly. Number J, 1,9. If you look at this, there's just a small dot there. And I indicated there that a number with a dot on top there, let me do it here. On the top there, it will indicate that dot on top, it will indicate that the number recurs. So this is J. This is J, which is 1,9 with a dot. So it's the same as 1,9999999. So this 9 will recur up to infinity. So this is a recurring decimal. So let's go back to our table to go and indicate. So is that number a natural? So I think the first one is just to tell if the number is natural. There we go, there we go, there we go. So no. So is that number a whole number? No. Is that number integer? No. Is that number a rational number? Yes. Recurring decimals are rational numbers, as well as terminating decimals are rational numbers. Is that irrational? It can be both. Is that a real number? Yes. So the square root of 16, guys, I talked about this type of numbers. You check the number on a calculator, it gives you an error. You must know that that number doesn't qualify to be either rational or even irrational. So this number will give you an error, undefined. So this number, it cannot be natural. It can be whole number. It can be integer. Neither can it be rational. Neither can it be irrational. So this number is neither a real number. So that number is non-real. So if you check these non-real numbers, they don't qualify in any of these categories there. So the last one, this one, I just want us to look at the value there. So let me activate my hand. So I'm going to erase as well. so that we don't find ourselves mixing these things up. Okay, let me activate my pen. Yeah, now we have the number square root of, or cube root, sorry, cube root of -8. Okay, so what are we looking for there? We are looking for a number that was multiplied 3 times by itself to give -8. And what is the number? The number is 2. Why? Because you don't have to give us this reason. I'm just writing for you, because -3 times -3. No. -2, sorry. -2 times -2 times -2 is negative times negative will be positive. Positive times negative will be negative. Negative what? 8. So the cube root of -8 is -2. So now let's go back and complete the table. I want a handy there. Okay. Now a pen. So yeah, now it's the number natural. So the answer there is -2. No, natural numbers don't include negative numbers. Is that number a whole number? No. Negative numbers are not included in all numbers. Is that an integer? Yes, it's an integer. Integers, remember, counting numbers from negative infinity up to positive infinity. Rational? Yes, it's rational. Irrational? No. Real? Yes. So, guys, we are done completing our table. I hope you also, guys, who tried to work it out, got it correct. So I just want us to go to the second activity, which is number B. So I want to number B and C. So let me stop there. So never mind the next topic, guys. Never mind the next topic. We're not going to do it now. Yeah, that is the second activity there. From the list, number B, from the list of numbers, -3, 3/4, square root of 2, square root of 9, 0, 2, and square root of -4. Write down all, number 1, natural numbers. Okay, I would want to work them out somewhere. Okay, this time around, let me go to the right-hand side. There's also a space there, nice one to write or to annotate. So number 1, I'm going to list all natural numbers. All natural numbers. Okay. The first one there, 3 is not a natural number. 3/4 is not a natural number. Square root of 2 is not. Then square root of 9 is 3. So that it can be the first one. Then 0 is not. So 2, it's a natural number, and 4, it's a non-real number. So natural numbers, remember, guys, are counting numbers starting from 1. So there are only 2 there. So number 2, we list all whole numbers. Whole numbers. So the sign there would be n with the 0 there on top. So if I can just move a bit to the right, just to put an equal sign there. And let me activate my pen. Okay, my pen activated. So ke tse di feng di-number tsa gona ama-number akhona we have, oh, first of all, we need to know these numbers. What are these numbers? Whole numbers. We know whole numbers are counting numbers starting from 0. So we look at the first one, -3 is not. The second one, it's not. The third one, it's not. The fourth one, which is square root of 9, which is 3, it is a whole number, which is 3 or square root of 9. So the next one, it's 0. It's a whole number. So 2, it's a whole number. The last number, it's non-real. So we're not going to include it in there. So the next set of numbers, it's integers. No, I've made a mistake. There's no R there. Okay. Integers. So integers, these are counting numbers, guys, as well. Without decimals, negative infinity to positive infinity, they include 0. So the first one, yes, it's an integer. The second one is a fraction. The third one is an irrational number. The fourth one, which is square root of 9, we know it's 3, so it qualifies to be an integer. So the second one is 0. 0 is also an integer. It's included in a set of integers. So 2, it's included, but square root of -4 is not. So number 4, all rational numbers. Rational numbers. So if you remember the sign for rational numbers, it's Q. It's for rational numbers. So the first one there will be -3. It's an integer. All integers are rational. The second one, it's a fraction. So that is actually, on a calculator, it will give you 0.75, which is also a rational. So it's 3 over 4. It's a rational number. So that one, square root of 2. Remember, a square root of a number which is not a perfect square, it's irrational, so it cannot be part of this. So the second one is square root of 9 because it's 3, and 3 is a rational number. So the next one is 0. 0 is a rational number because it can also be written as 0 over 1. So 2 is a rational number. So those are all the rational numbers. So number 5, we need to list. We need to list irrational numbers. So the sign for irrational numbers, remember, it's a Q with some hyphen there, or hyphen. Okay. So these are numbers other than rational numbers. So the first one there is going to be the square root of 2. Yeah, it's only the square root of 2 there. It's only the square root of 2. So the lastly, we want the real numbers. I wish they would have asked, I wish they should have asked about the non-real, because it's only one there. So, but it's fine. We can write them. So real numbers are real numbers. So there's this other R that they normally write. Real numbers, the first one is -3. So the second one is 3 over 4. The other one is square root of 2, square root of 9, 0, 2. Yes, 0 and 2 is the last one because the only number which is not real there is square root of -4. Like I indicated, that number is non-real. Okay, so I want us to go back to number C. Number C, we are only going to state. I think he's not going to take most of our time. State whether the following numbers are rational, irrational, or neither. So your answer is only going to be rational, irrational, or neither. So you can only have one answer there. So number one, that is a cube root of 33. So 33 is not a perfect cube. So that number is going to give you a decimal, and a decimal which recurs. So that number is a non-terminating and non-recurring decimal. And non-terminating and non-recurring decimals are irrational numbers. So the second one is pi divided by 2. Remember, when we divide a pi by 2, or you multiply a pi by 2, or by any number, I think that number is going to give you, again, a number which is non-terminating and non-recurring. So that number qualifies to be irrational number. So the next number, with number 3, is 4,012,354. So that number is a terminating decimal. So terminating decimals are rational numbers. So the next one is number 4. It's square root of 1 over 121, which is the same as the square root of 1, which is 1 over the square root of 121, which is 11. This number is 1 over 11, and 1 over 11 is a rational number. So the next one, this number is non-real. If you remember, a square root of a negative number is non-real number. So it's undefined. So this number is not a rational number, neither this number is a rational number. So it's neither. So the answer is neither there. So number 6, negative square root of 2. So square root of 2 is going to be 1 comma something. So, but now the answer there is going to be negative 1 comma something, which is rational. Number 6 is rational. Number 7, that number divided by that number. So guys, any number divided by that number except 0, it's 1. So the last one is number 8, a cube root of 27 plus 1, which is going to be a cube root of 28. And a cube root of 28, since 28 is not a perfect cube, is going to give you an answer which is non-recurring and non-terminating decimal. So since it's non-terminating and non-recurring, is going to be irrational number. Okay, guys, that marks the end of these activities. Like I said, I'm only going to discuss the real number system. So guys, just to recap just a little bit, we've been looking at the real number system, and we did some activities then to categorize the numbers according to different categories which follow under the real number system. Under the rational numbers, we said we have integers, which include whole numbers, natural numbers, and non-integer rational numbers. Non-integer rational numbers, we talked of recurring decimals and terminating decimals. All those numbers that I've just mentioned follow under rational numbers. So another branch of numbers, we said, it's irrational number. So under irrational number, we have only one type of numbers. We have the numbers which are non-terminating and non-recurring decimals. So this must be the same number, which does not recur. At the same time, it does not terminate. So terminating, non-terminating, and non-recurring is the same type of a number. Yeah, guys, until we meet on the next topic, which is going to be multiples, vectors, and prime numbers, I want to say thank you for staying until the end of this session. I hope it was fruitful. I hope it was also reviving. Guys, I hope you also participated in the activities that we were just working out in this session. So, guys, again, those who have forgotten to subscribe the time I requested, please subscribe so that next time when we post another content, you will be in the know. And you can also click the notification bell there on top. Guys, somewhere, you are YouTubers. I think you should, there's something which looks like a bell there. So that next time when I upload a new content, you are one of the first people to know. Once again, thank you for tuning. For other things, like I indicated that I will also upload the link to download this document on the description box and the other important information so that you can be able to reach out to me if there are questions that you want to ask. Thank you, guys. Thank you. I really appreciate. Sharp Sharpo, Tango, Tovela Galebo. Thank you, thank you once again. This is the end. Stop.